it's me, Davay, and today I want to present you the new package that I have released in our organization, and it's called HashFS. It's for encrypted browser storage. So this package allows you to have some files. You drop them in the browser window, and they are stored encrypted, just right there on your on your machine, and you can access those encrypted files through this system. And it's built on Vue.js, and it's a composable, reactive composable, so it's very robust and easy to use in a Vue context. Yeah, it's quite narrow focus by now because I have that much time, and even with all the LLM help, it's not easy to bring all of your focus to so many tasks. But in a couple of weeks, just wondering about encryption and how it is working in this wonderful package by Paul Miller that's called Noble Curves, and yeah, it gives you so much that we can really create wonderful things in just this size. It's just around, yeah, it's very small size. It's less than one picture, and it's backed with curves, and it's backed with ciphers, and it's very interesting, and hashing algorithms. So what do we have? This is already old, and that's the case why I'm recording this at this version, because I broke many things. This is already wrong, and many things are a little bit old because I want to go rapid and before anyone uses this, because I want to change things rapidly, because all of this of course is open source, and we can just start playing with this. Okay, right now. Okay, so we go just to this wonderful domain name. Thanks for guys who organized the js.org. Big respect, they approved my address here, and so we have this hash F and S here. Yeah, this version, it's secure browser storage, so you can input some text, and what will happen, you will have some basic storage. That's it, that's the demo. Okay, and let's see, we have npm, we have GitHub, we have you can just install it and use it in your Vue application. And not only Vue application, you can use whatever, but really you need Vue for this. At some point, of course, we will make it more universal. It will be class-based or whatever, but for now, rapid development. I just spent 2 weeks in the field that I know, and I built it in the way that I built it. So here we can come back to this storage again. Let's create a file, readme.md, for example. We like to start with this. It's not a markdown editor here, it's just text area. So no formatting, but yeah, we save it every 1.8 seconds of spare time, like this, and it's like it's saved. So now we have 3 versions of this, and yeah, we will need to maybe drop one of these test recordings, for example, here. Yeah, processing, it's processed, so now I've dropped it here. Yeah, I can it's not refreshed properly. Yeah, we can just refresh the page, and what will happen is the key that was generated for this encrypted storage gets generated again. So if you want to enter and like generated key is stored only in the session of this browser. So even if I open another tab, it will be another session, so it will be lost. So it's quite a safety measure, and there are so many safety measures. It's just crazy. But yeah, here you can see that we have undo redo functionality, and it's hashed approved, and it's like verified. Not with Merkle hashes now, but yeah, still it's working. We're storing about like 10 copies like persistently, but per session before we prune them on load or on save or export, we can have more steps stored, because like the hash chain is stored forever. Like we build hash chains for every entry, and yeah, that's quite interesting. We can download this and have this as a zip folder with all of that. Yeah, you can see it by the size. And okay, so the download zip and also import zip, you can just import it back. You can import files, we've already seen this, and yeah, you can create new. This is nothing special, this is just for testing, and this is a demo page, but the important thing is that it has all these serious cool things inside, and I'm quite excited just to show the code and explain how it works, because here it is all like not actual information, and I will explain this of course and describe it. First I want to explain the idea behind this, and then we will be on the same ground if you are interested in using this library or contributing to it. So what we have here is I have it open in my VS Code, and we can just look around. So it has a package.json, of course. So we start from this is JS project 2.4. This we've seen this here. So this is a non-line version of this thing basically, and we have these commands that I have down there. And what we have in our dependencies, like what I declare as like direct dependencies, are those beautiful, noble curves, ciphers, and hashes that are encryption made in JavaScript efficiently, and it's beautiful. I love it. I'm so inspired. That's maybe what inspired the whole project, when I understood that we can just rely on these without even web crypto and stuff, and this is very, very good thing that Paul Miller built. And this is very good thing that I'm sorry, I cannot mention all the authors like Evan Yu, and of course Anthony Fu, and yeah, guys from Iconify, and yeah, Bog, again Anthony Fu, again Evan Yu, yeah, and WebTorrent guys, yeah, amazing things. We're not using WebTorrent by now, but I'm planning to work with it. It's a secret, okay, but just think about what we have already. We have this page and it's rendered with Vue already, so I'm using Vue, and that's why. And it's something strange. So okay, where it starts, it's a Vite build. Vite build is what we call from package.json. So here we have Vite as a dependency, and here we have this dev and build commands and lib command to build the library, and preview to preview the build HTML, basically what's we having. So we have an HTML that will be reactive and hot module replaced in development, and in the build we have it solid HTML file, and we achieve one wonderful property, that we use this Vite plugin single file that's just enabling us to pack everything we use in our application in one HTML. So it makes everything work in a very special way, and it's beautiful. So we have a port and servers, so we can run a server that will serve our development and preview if we need. So I have this Vue it's what I'm explaining you now how my Vite build is already. So we have this next step to build this HTML preview, and also there is another configuration to build the library that we provide on npm. So I can let's go through maybe library is even more correct. Yeah, so this is how we get the library, and we have we actually don't need these presets and stuff, I believe. Yes, but I'm not supposed to edit code right now, so we're doing this. We have a library build that takes this file and just builds it. So imports all the imports, and we inline all of these imports. And yeah, so what is delivered on npm is this use HashFS JS that's exporting some of the fun things already with Vue reactivity. That is a peer dependency. You need to have a Vue in your project, and it will just use that instance of Vue, and it will be working very nice. Yeah. I don't know. Yeah, it's easily made to work without Vue in this level, but I didn't have time to do this. So that's what we have. I enjoy Vue. I enjoy reactivity. Not every time like this, of course, because here we have to play with this thing. We have to have it on one layer, so we have to calculate every time some things that change, and that we need to watch this. And this is basically watching these properties, and whenever they change, we have this updated. So for me, it's the easy and cool way, because these are like lazy loaded, and if you are not triggering this and you're not asking much, it won't be running too much. And yeah, it's very efficient. I have a Vue, and Vue, guys, yeah, it's amazing. So we have init function. Like, yeah, of course we have global state, but it's not exported here. So, but yeah, we have auth files, and yeah, some managers, handlers. It's just, yeah, the core thing is that, yeah, we have statistics, we have loading, and file instances. This is already quite important thing. Okay, initiation, we get this global state worker initiation, and this becomes interesting because the only import we have is the worker. So this is basically a thin wrapper around a worker that is doing all the things, and we just send data to it, and we await it, and we get the result. And it's really powerful thing, because this happens in another thread. It's not connected to our main thread in a way that it takes our processing. That's why when you do something in HashFS, like you go and put this line to store some data there, and this is the beauty. So when you are you see the input is still there, we can hover things. All the encryption and decryption happens in the background, because encryption takes time. This is why this is loading. It's local files, but we need this longer time encryption decryption algorithms that will slow down the attacker, because these files are stored just locally. So all right, we import this, yeah, and these are like small tricks, yeah, for the peer dependency thing and for inlining all these workers. So we have the worker inline, and when we just, yeah, okay, let's just hit build and just see that we have this 200 kilobytes HTML, but JavaScript that we are building from this HashFS is just this size. It's just small. Just really small when you think about it. and it's encapsulated with all the encryption in it. Yeah. So let's go just look through it more. So you understand that reading these, you will see basically going down to this worker managers and things, and you will see import files, and that's it. We to import files. We of course work with, like, we establish our operation to have this progress thing going. It's a cool thing. This was yeah, I still need to comprehend this better. It was a little bit of vibe coded thing, but still it's there because, yeah, of course I use LLMs to kind of improve this, and this was a gamble if it will work, and then Claude and ChatGPT will understand this. Like my code style, but yeah, at some point when I feed them with enough of my code, my style, and give guidance, yeah, at some point it gives some good results. Yeah, it is one of them, but still, the main thing that why I'm recording this is that I'm having this mental picture of this, and that's what I want to share with you guys who's watching this sometime later. So of course, yeah, export zip, we just export zip. This code is nothing interesting. Import zip, okay, and then we have init just on first call, we run it, so we run it every time, but yeah, there's some thing to prevent some over initiation, and of course we like have a close, that's very important. We terminate on close, so it's cool. We leave the session, we terminate our worker that has all the encryption and all the keys and everything inside, so we don't have anything in our memory in this main thread. So, and the worker is in line, so it's just pure security. And then you have download basic thing, and yeah, that's it. So it's an interface to the worker that we have. But what is interesting and important is this addition that comes like in half of the file. So there's the second part, and probably it will come like is really like a second composable that will kind of reuse the same worker or something, that it kind of needs more orchestration. If like, that's how I build it for now. Okay, so we have create file instance, we have the use file, and yeah, we have the caching going on. It looks fine and fun to see files just jumping around very fast, switching after, of course, they decrypt, because we encrypt everything, we compress everything, so it's sometimes it can take time, but you can do whatever else in that time. Okay, this is the fun thing. This is where we kind of start understanding what is this HashFS. Okay, it was all the blah blah blah, but now we have use file that provides us with a very good interface of rename, delete, import in place right here, export, and this is the instance. So it's loading, its file name, its MIME type, it's very important. Text, if it is text, bytes for every file, dirty if it's not saved before, if text changes, for example, or bytes. And then current version, available versions, can undo and undo. Yeah, this is what all the hash chains are about. And then load, save, rename, delete, import, export. Yeah, of course, we cannot mention these words in JavaScript directly. These are forbidden. Of course, they are reserved, but yeah, we should have these names. Okay, so the interesting things should be in the HashFS worker then that we import. And really we have just only two imports here. So alright, we have this IDB package that's also wonderful open source thing, and you can have OpenDB, and you can just work with your IndexedDB in a fun and easy way. I love it, and it's tiny. So we load IndexedDB. That's where we start. Okay, so here we're storing data in IndexedDB. Why not OPFS or something? Because it's less stable. IndexedDB is a solid thing. It's really solid in browsers. It's like corporate tested, bank tested. It's really strong, good database, but it lacks encryption, and that's where this idea of HashFS comes. So we open DB, but we already have a chain manager that takes our keys, encryption key, but for signing it uses important functions. And yeah, this is where it is all becoming interesting, because we really start to work with encryption, and this is like the last layer of the application, because this is still high level abstractions for load files. So we have these top level things, but we already have database operations, and this is mainly for database operations. So encrypted we get from the files, we get versioning, and it is complex. But what I want to like note some of those things is those recent changes and my cryptography decisions in 2.4 and how it works now, because it works. I cannot verify all the cryptographic reliability right now, but I believe all the research that I could find about noble and noble curves, and I use only them, and maybe you can spot some mistake or a vulnerability, and I would love to just fix that easily, and it's open source guys. So we have save file again, but now we already start hashing things. You see, this hash is used later. So if content is unchanged, we deduplicate. We just save metadata probably, or no, we just skip this. So hash says it's the same file. So we don't save the same file again and again, and that's already a good thing. But also we start doing these things. We have keys that are signing these hashes, and these keys are derived from the input. So all the keys are derived from the input. It's your password that what just makes everything work like this. And we are generating things, then bump the version on save file. We compress things with Flate, then we encrypt them with our utility. So you see, we are operating on this high level. We don't say which curves and all the maths. We just skip this. We just operate on this high level in the worker, but we're already in a separate thread. It's beautiful. So we start saving with atomic saves to the database, and we just add these files and meta and open this transaction, and we start writing the encrypted data to the object store. So this is a compressed, hashed, signed data that is going. So we got file bytes. File bytes is the initial thing that we got from bytes that come from data that comes here. So this data is the bytes data of this, and it goes into into save file, and then we just have this save metadata, and the transaction is done. So this is quite a complex structure, but you can see that we update metadata and just store like global metadata, I would say, and save it. And you can see what is this save metadata is we have these files and schema version and bytes of this data. So files and schema version, that's what we have, 5. Okay, I didn't know that. That's good. I would need to synchronize this version. Okay. Then we have bytes, then we encrypt them, and then we save them. So we have this metadata stored on every save. So save file, delete file goes directly to the transactions, but it also goes to chains and remove the chains. Excuse me. And yeah, rename, export zip. So of course we would have to go through all the items that are all the files. So you kind of also should be getting the idea that we have this metadata thing with files, and we update this and operate on this level. And yeah, we have all the database operation. And also, yeah, you can note, for example, that on here on we store MIME types, MIME types in this hidden file in the exported zip files, because zip doesn't store this information. Yeah, but I managed to find this way. Yeah, it is a not ideal and doesn't solve all the problems right now, but yeah, it's a small solution to a small problem. Okay, and create zip. Yeah, so we can import and export the zip vaults, like complete lists of files. And yeah, they're unencrypted. We don't care about encryption. They're just open, and these are just packages that are used to transfer between maybe places. They can be opened in the same way like you have files on your disk. These are not safe. The HashFS is safe, is the safe place. But yeah, we can encrypt zip files too, also in the component, in the UI, in the client. Just by now, I love that we can have such a small footprint with Flate. Maybe Flate has support for encryption. Okay, let's see. Let's go further, because we have so much encryption layers and so much to just cover a little bit before I finish. So get file list, you can see we also just go to this metadata. So metadata is important to keep it intact and synchronized, but we already keeping it. Cleanup to really like remove all the stale things and ghost files and invalid content, orphaned files. This is a big thing. This is where AI gets very helpful, because this is direct continuation of the first half of the file. So this is where it shines really, and we should, I think, have benefit from this efficiency and coherence to the text. But now we're not talking about really like text. It's more about this meta structure of the project itself, the idea, the ideation, and the purpose and authorship that I'm kind of presenting right to you right here. So this is the class that we are importing, and not importing. We are we are in. We have this as a class, so it's not Vue here. We don't need a Vue in any way. It's worker. We don't have UI, we don't have window here, but yeah, we have classes. It's very convenient here because now we have this convenient worker class, and we can just bind it to our interface that's facing the main thread. So on every message we will have an ID type and data, and depending on the type we will just get this information, because we need this information just to start working. We need this passphrase, and it should be 8 symbols long at least. Yeah, if you cannot log in, maybe use a longer passphrase. So Okay, and then we just have all these bindings with also operation IDs sometimes for bulk operations. Yeah, so we can have the progress bar running. It's beautiful. Yeah, and get files. So this is the interface, and we have this interface provided with all these transferable objects. So because finally we kind of consolidate all this data, and it goes into this post message and it ID success, and result then is having this transferable array of buffers sent back to the main thread, and that's where we get all the bytes. And bytes are the true and main language that, and the only language these things speak. Yeah, there is ID success error, but there is transferable data, and yeah, it can be sent or it can be an error. So this is the hash worker on this top level, because we just have storage managed here in a profound way with chains and stuff, and we can see the structure of the library is basically, I would say, this is what I've built, and I think it's what we need for FS, and this is what's making it FS, and hash is what is making this part. So we need to just take a look at this crypto.js part to analyze, and I will just show you through the code, walk you through the code, and we can just discuss maybe something can be changed, optimized, or just take the note that it's just my 2 weeks project, and I'm not an expert in cryptography. I'm just excited to use a lot of it to make this hyper secure file storage just for fun, just to explore things. And you see, I explored a lot, and so we can just analyze it deeper. Maybe even this will change, because I've introduced this Blake hashing and all of this. I'm just barely understanding these things, but really this one is a cool thing. This overall, it is a cool thing to play with. And I can just walk you just briefly walk you through this object. It's just an object cryptoutils with a number of functions, and you can see all these functions, so we can read them. Just a small overview that, of course, we have derive keys. This is the most important part. Then we have hashing, and it's just Blake 3 hashing, whatever it means to you. It means for me that it's quite modern, quite robust for our application of hashing basically everything in the app. So this cryptutils hash is used in the worker for hashing. There's chain ID generation. It's just random bytes. It is just UUID generation here happening. That's where we kind of lose or keep track for the blobs and our keys with chains. Encryption is just AES encrypt, so we just import this GCM, yes, key bytes. So again, we operate on bytes, so we get bytes, we GCM AES, then we encrypt this ciphertext, and we have this IV vectors and ciphertext stored as data. So this is encryption, and of course decryption goes back with the payload, IV, and data. Compression are just two small utilities to have these callbacks of inflate deflate in promises, and it's just small things, small footprint. And chain manager. Chain manager is quite complex. It's hard to understand, but we have DB chains IDs, and we have this information there with versions. This is like our true thing. This stored is very like important, and it is encrypted separately in chains, and that's why we have to decrypt it, and we have to inflate, so it's also compressed. So these are encrypted and compressed things. We will believe these are our file tracking dossiers. It's like logs for our files, and each version will have information about the hash of the file. So this will be verifiably and signed. The hash is signed that you put it there, so you can verify. Even if you get it decrypted, you can verify all the hashes that go like to the start. So this is a very secure part, and that's how it's working. We decrypt the file and deflate this or inflate this and verify chain signature. So it should signature is over decompressed bytes. So we hash the decrypted data, and then we verify the hash with signature, and if it's failing, it's failing, and we are going to chain load fail. We won't have it imported and run. But if it's working and all it's verified, we have this inflated chain object, and it's just the JavaScript, yes, with versions, and we will use those versions to load things from them. So this is a get chain and save chain. Again, we will have a chain ID and a chain object. I believe it's like updated. No, it is the bytes that we're working with. Compress. What we need, what information. So this is basically a JSON store, also encoded, compressed, hashed, signed, encrypted, and put into you see along with the signature. So it's encrypted signature along with IV and data. We will have the signature there. It will get put into the chain ID chain inside this chain store. So this is the save chain, and there's add version. Save chain. It's all goes to versioning. It is when we are again it's where we prune older things. So 15 versions we store, and then we start pruning them. We just prune those older stores, but we use this add version whenever we want, so we can run it and not even on saving, not on every save, and even not on load. And we can make this configurable. It's all like bare. It's also fresh, but that's why it is important, because now I have the full mental picture of this thing. and then I can explain it and I can show you around. And yeah, that's it. So chain manager is a cool thing. It's just working with files. And also there is a cool key derivation that we need to cover yet, because this is the core thing. That's because we are encrypting, we're decrypting, and this is this AES that is using key bytes, and for every encryption we need key bytes. And you see we have encrypt compressed and encryption key. An encryption key is what's coming into the manager, and it's what's provided by the derived keys. And derived keys do the important job. We're using these keys for throughout the application, and they are derived from the password. And password is just put something, just eight symbols, and you're good. This is very low. This is very bad threshold. This is very unsafe. You should not use passwords like this short. But it is testing thing, and you're not supposed to store really important information anyway right now, because it is very early version. And yeah, of course, if you reuse the same version, you will get the same store, you get the same result. But yeah, of course, now it is like this. You can play around, you can just put whatever, just tap around at least 8 symbols. Okay. This is a deal, just to have it. Okay, and of course there's the salt. That's one of the ingredients, and we add just HashFS salt. Yeah, it will upgrade. It's quite open, you can see that in the app, but yeah, still you will have to calculate all of these fun things that go into this script, noble hashes that we use here. We don't use this async version because we are in the worker. We can enjoy the worker setup here. And then and this sync thing, that it's just working on its own thread. It just goes does everything in sync. No need for this await thing. Okay, so what happens next? We use the script curve. Like, yeah, it is a cipher that can extend the bytes with the salt and these numbers that will make anyone who wants to decrypt and like have the same master key established, they will have to take random passwords or guess passwords, use the salt is provided with the app, and calculate this crazy number of operations that will take memory. Not only calculations, but also memory. And because of that, it's quite expensive even now, even with all the computing and parallelization. And then guessing passwords for this particular setup will be a tedious task. So yeah, probably with quantum cryptography it may be broken someday, but yeah, it will be expensive anyway. And we can make someday maybe post-quantum cryptography, but now I'm on the edge of like modern, good, like secure things that are good for use in upcoming years, I would say, and maybe tens of years before, maybe even decades, yeah, because before any of these quantum promise comes in. Okay, so we're using script. Then we have the master key that we use to derive the signing, yeah, with the same salt, in a signing and encryption way. So these are two special keys that we are using. It's important to use both two of these. It's safe. It's more reliable to not just use the key, the master key. Even it's better to not store it anywhere, so we will just have to derive it every time, and this is the beauty of it. So yeah, this all what's happened happens on the load, and that's why it's kind of slow at this point. So it's like whoop, and this time is where all the memory is used and all this calculations is happening. So depending on hardware, it will be slower or faster, but now it is not only about the speed, it's about the memory. If you can provide memory, okay, you can have a guess, but yeah, it will get problematic like altogether, and we can bump the numbers. This will be a breaking change, but yeah, you can just use the version that you had, and just now it is a development. We will think about like how to make all of this like transition when we change things, so they will re-encrypt things safely, but now it is a big pain, so sorry, we are just on the edge. It is just my pet project. But what I love is that it's working very reliably. I can see the speed, I can verify it, and this video is this confirmation that I understand what I'm talking about here in this code. Because we're having the Blake again, so we're having the key, pub key, and this is our database name. This is our public information that's accessible in the inspector. We can go here, and we can see we need to find the one user that has everything. Yeah, so here we have encrypted blobs with these names that are kind of random. We have chains that have this UUID also, and we have meta. This meta is the core, and its index is also encrypted. So only encrypted, not meaningful data at all under this not meaningful at all part of the hash, and it's already very long v6 database. You can see it here. So here we go. We just put this database name provided when we return this on initiation. So when we get initiation, we get password, and we return signature key, pub key, encryption key, full. So yeah, we just export it. I will verify. Maybe we can just keep it inside. Yes, let's see. DB name. Yeah, we can. I think we can just keep encryption key inside. Let's see in next versions. So sign and verify are like this, are provided as functions. So you can ed sign the bytes, and this is ed 25519 is the good and reliable curve with signatures. So this is sign and verify, and it's like cryptography and hashing and generate key. Okay, now you have seen, yeah, this is just random bytes. So again, we have random and random, so two random things looking differently but are basically the same thing inside. Yeah, maybe we can like make it the same, work in the same way, but yeah, it's not a big deal right now. Yeah, so this is how it's working. It is I've shown you only the dive down. So this is the library that we're talking about here, but also there is this application that is available on GitHub pages. I use GitHub pages and jazz.org. Amazing domain name that I was provided. Thank you, the authors of it. And yeah, here you can see that it is HTML and it is Vue component. So Vue takes some part, and it is what's making this work that funny, in a fun and cool way, that you can just use some text to start working with, start storing some data that is encrypted, and you can just forget about it, and one day you can just come back and find it there again. But of course not with this particular website. You would have to, for example, download the HTML and use it from your safe system for to have it really reliable, because we will update things. You will lose storage if you try to use this HashFS. You're not supposed to store really important things here. What you can do is go to the releases, and you can see, oh, I didn't add another one, okay, but yeah, so you can have this index HTML file, and this is amazing thing. You can just open it, and yeah, the image is not present, but the storage would work, and the storage would work in such a way that it will be like 100% reliable. Why? Because it is a local file, it would never change. So if you open it in the same browser, it will open the same IndexedDB, and IndexedDB is very persistent. Users don't clear up IndexedDB often enough, and you just don't clear it up in this browser that you use to do this. So you can have some document that will be really preserved there in the browser cache, but yeah, the path to it is what matters, and don't change the path and don't change the password. Yeah, it's very secure thing, it's fun to play, and that's why I'm building it and sharing it with you guys. So yeah, that's where we are now. And one last thing, so it's a single HTML, guys. I love this thing, and it's not only just a single HTML file, because you can do this. You can add to doc. You can say, okay, I will replace it, and I will have it in my doc. You cannot see it, but when I click it here, I can have this PWA running like a desktop app. So I don't need Safari, I don't need my any kind of code there, and I can just have it there doing its all the fun thing. You won't have access to the store that you've even you see there's no selection. It feels like desktop app. Wow. Okay, and we enter, and yeah, you will get another storage. So don't expect the files to magically kind of go around all this encryption. No, it all depends on the place where you're running the code. It's very local. It's really like a vault in this particular place, and yeah, it is not a product, it's just a library for developers, for me to use in my projects. That's why it is a Vue composable in the first place. I don't provide any like file editing things or nothing, no servers, no tracking, no data leaks. It is just the Vue composable package that I provide, and you can play with that. It's fun. You just use your phrase, and you auth just automatically, and you use file. You can control export import. You use file to get a file, and with the file you can do whatever and save it whenever, because you can configure, of course, the time of updates and storage. This is the product. No, this is the projects that are involved, and yeah, I want to, of course, show you how it is a very cool in terms of provision. So you can see that version is built and signed on GitHub Actions. We go down, we can see that provenance for this is GitHub Actions, and we can see the build file that is running this. So on tags with V, we dispatch this action, and it is running this in the provenance enabled mode. So we have a checkout, we set up node, pnpm, that's what I use. We install it, we run lib, so we build the library, we run HTML build, then we create release for this, and in the release we put those two files and publish. So we put the release on GitHub, with this all this GitHub information, and also we publish this with provenance and public access. So this is open, this is working there. You can see when it was run, and that's where it becomes so good, because it's very verified. And I didn't make a release to this tag, but it is there. So full provenance, so whenever I put a tag, and I should know how to make them also verified, because all the commits are verified here, should be. No, not verified. Oh yes, they are all verified from the start. So you can see it's very, very secure. That's what I like. That's what's my skill about. And then it's hosted on GitHub pages, and it's going into this js.org domain. So it's like forever. Thank you, Microsoft, for having this and offering us all this for free. I hope you don't abuse this, because I don't want to think about the abuse. I want to think about the privacy and basic human rights that are achieved with this library. And it's nothing special. People just can have their private vaults, and it is normal. We need to store some documents, we need to make sure that we have some stash hidden. It is a human thing. Everyone wants to feel safe by knowing something that no one else knows, that you of course can just copy this part from provide to secure, but make sure the version is the same, and make sure that you remember the password. It can be extended, it will be extended, I will be building on top of it. And I try to be as generous as possible with my debug project, and with my intentions. I want to make the world safe, I want to make the world bright, beautiful, open source, with open knowledge, and with freedom that is achievable. And we have everything that we need. We just need to coordinate, and we need to be honest, and we need to be clear and transparent. But this comes voluntarily, and first we need to establish that a person can have something in their browser, and it's fun to have it somewhere, encrypted thing. That's the tool. So basically, having an HTML file will be the application itself. It's the distribution, it will work indefinitely. It's a solid thing, and you can just basically save pages. Let's just do this just to see if it works. So I will open this again, and we will try to start. Yes, it's working. So you just you do what you do. You can do whatever. It's MIT, because I don't have to take all the responsibility of what people do with it. I don't make any storage solutions for any data. It's my contribution to open source. I love open source. I know that people can use it now to vibe code cool things, and stay cool. Have this start this repository, and just go for it. Explore cryptography, and we will grow. We will just invent new things, but really I want to keep it easy to use, fun, with no bloat. And we can, if you're interested in extending these, we can discuss how this can work. It's a big thing. We have time, It's not some hype. I'm just trying to build web and make it fun again. And it's working with LLMs and stuff with as our helpers, but don't get deceived with them. If you find any flaws in my code, please contact me as fast as possible. We will fix all this. Thank you for being around, for listening and looking through this code with me, and see you next time. Bye.